We're here to talk about why experience is the new uptime and how Session Smart delivers. Is our VP of Worldwide Sales, Tim Ziemer. Tim, do we have you?
You do. How are you?
I see you. Fantastic. Good, good. I like your background too.
Yeah. Oh crap! I didn't put it on yeah. Anyway, it's
no,
backwards.
It looks fantastic. All right. So we've got you for 30 minutes.
All right. Brilliant.
The floor is yours.
All right. So thanks for spending time with us today. I mean, we're super excited, not only about this technology, but how the industry is really kind of rallying around where we're going. Things are lining up just perfectly. So, why does the network exist at all? And if you've ever asked that question, certainly CFOs are asking that question all the time. Why do I have to manage my network at all when I can go into a Starbucks or into my house and get access to broadband? And really, the only reason that networks exist is to deliver experiences. And that is Juniper's focus. And the only way to deliver an experience is to connect all the pieces that are necessary to deliver that experience. And once you do that, you also have insights that allow for things like AI to watch what's going on in the network and improve it. And this is Juniper's vision. And so, I was one of the original guys at 128 Technology, and I'll talk about that. So 128 was founded in 2014, as Reed had mentioned, and we've been really believing that networking was too much about connecting IP addresses to one another than around delivering those experiences. The only reason these networks exist is to deliver experiences, and rather than create overlays, our focus has been on innovation and IP routing itself. And so, people were asking in the chat about where the name come from. If you were to pull up a map of the internet from 1969, more than half of it was along Route 128, which is a road outside of Boston, connecting BBN and Lincoln, Mass, with MIT and Harvard. The other half of it, of course, was over in California. But really, IP routing was essentially born off of Route 128, and so the name is just a tip of the hat to the area from which we hail. If you look at, let's put into context why experience actually matters. We're all working from home, and I can tell you exactly when work from home, when the kids in my neighborhood start logging online to their online school because the experience goes bad. So if let's put this into perspective as something that we all know well. Why did Bob's video call drop? Was it the Wi-Fi? Was it a bad Ethernet cable? Was it a problem with the Zoom application, his PC, or the internet connection? With end-to-end service levels, once we can correlate events, detect anomalies, and allow the network to be self-driving, you can easily discover which of these issues it was. And what I want to talk with you about today is how 128 contributes to Juniper's client-to-cloud vision specific around the WAN. So 128 Technology, I want to just talk a little bit about why we win. When people are looking at different technologies for solving these issues, the first is the visibility that we're able to provide every session. And if you think about a TCP or UDP session, it's like the thread it's the only thing that ties all of the resources necessary to deliver an experience. So storage, compute, application code, the session is the thing that ties all of that stuff together. And unless you have visibility and insight into those sessions, you don't have the ability to guarantee an end-to-end service. And so we're providing much more granular visibility into what's going on. And it also has a number of other benefits. You're able to break through with economics and scale. Because we're not using tunnels, we can have much better performance out of every single head-end resource that we have. We have a significant reduction in bandwidth, which we'll talk about. You can deploy it much more quickly and efficiently. And you can also have more available bandwidth for every single site that you have. From an agility perspective, I think you've seen some demos, and we have more online, and we're happy to book them with you. We literally can click a button, use CloudFormation templates, and spin up a router and start load balancing to it instantly. And from a security perspective, really is second to none. We're going to go into some customers and how they're using it. But the whole notion of routing sessions gives you this whole directionality where you can keep track of where a session started and where it ended, and you can control who talks to what and how they're able to talk to one another by taking that, the who, what, and how, and baking that into the data mile, how your network is actually configured. It allows for a much more control of what the network actually delivers, and it makes your life as a manager of a network much easier. So let's geek out a little bit and talk about overlays versus routing. So we talk an awful lot about tunnel free and why, I want to get into why that actually matters. So first, the tunnel, to the routed infrastructure, all the routers in the network, a tunnel, whether it contains one session or 50,000 sessions, looks like a single flow, causes all kinds of problems. There's no way for the router itself to choose a different path for certain packets in that tunnel. It's kind of all or nothing. And so it creates this one lane highway, which also causes issues because if you have bloat in the tunnels, which many of them have, you have 30% additional bandwidth that you're chewing up. Just the dirty little secret of SD-WAN is that you're actually adding a significant amount of bandwidth to every single packet just in overhead. And so this causes all kinds of issues as well. And as these packets grow, you're naturally going to have significantly more packet fragmentation, which causes retransmissions, which exacerbates existing brownouts within the network. And so fragmentation is an issue. If you do have a brownout and you have an overlay-based SD-WAN solution, one of the big things we've noticed is that everybody demos their failover of voice or video calls in the demo. But what they don't tell you is that unless you have both active and standby tunnel running, the session or the tunnel initiation time for that backup path can be measured in tens of seconds or even minutes in some cases. The larger the network that is, the more complex, the bigger the n squared problem, and you have all kinds of issues. So the failover doesn't work particularly well for real-time applications in the real world. And from a security perspective, we already have enough on our plate, let alone heaven forbid you ever compromise and you actually get into one of those tunnels. It's kind of like having a tunnel past the wall of the castle. You can actually gives you a route directly into where you need to go if you're trying to do something nefarious. There was a very public breach within the federal government, and the only way, and the hackers were trickling out information from the Office of Personnel Management literally for months or maybe even years, and they were tunneling it. They actually were using tunnels to extricate data from the U.S. government, and so tunnels actually are not a great thing. Bottlenecks, you create issues when it comes to these artificial architectures that you have to have, the hub and spoke topologies that you're really forced into. You have a choice between an n squared problem with a mesh where anything can talk to anything, or a hub and spoke where you have these huge aggregation points in your network. And so the ability to actually route sessions where they need to go is extremely important. So this is just a couple things on tunnels. And so you might be asking the question, well, if you're not using tunnels, how does this actually work? How can you securely get things where they need to go without using tunnels? And so I'm going to geek out with you for a minute. And on the left-hand side, you see a source. On the right-hand side, you see a destination. And you have a network of Session Smart routers. Now, there could be just one. There is significant value in just having one Session Smart router. You have visibility into the sessions, and you can have the ability to route to different interfaces. But when you add multiple routers into a network, the value gets even more expressed. And we'll talk about how this actually works. How are we able to route based on sessions and not using tunnels? And so I'll explain a little bit about how this works. So a packet arrives at a Session Smart router, and between them, it's our service-aware network fabric. So basically, any network that contains multiple 128 routers, we're calling it our networking fabric. So the packet arrives and we detect, is this part of an existing session? Do I have a policy for this packet? If the answer is no, we then look up the policies. And again, I talk about the who and the what. Who's trying to access what kind of service? So we have this notion of directionality with routing. And so we can say, okay, this is a quarterback from the NFL and he's trying to access game video. And we know the who and we know what. And then we determine, okay, this is real-time game video. Is there a policy for how this needs to be delivered? And the cool thing about Session Smart Routing is we make decisions based on SLA on ingress to the network. So when that first packet arrives, based on policy and based on real-time network events, we can decide how we're going to route that packet through the through the network. We then take that first packet and we NAT it to the egress interface of the routers. We call these waypoints. If you're familiar with session border controllers in the voice world, it's how SBCs anchor telephone calls and video calls. We're doing the same thing for TCP and UDP sessions in general. And so we're able to NAT the packet. We take the original source and destination IP address and port number. We attach it essentially as a cookie or as metadata, if you think about it that way, in that first packet. And we then decide how to route the session and we send it on its way. When it hits that egress router, we take that information out of the cookie and we restore the packet 100% to its original state. And so this is really powerful. When that second packet arrives at the Session Smart router, rather than have to add another piece of metadata or another cookie or another header, we simply use the source and destination 7 tuple, so IP address, port number, protocol type, physical interface, and we use it as a dynamic tag to associate that session with the existing policy that's set up for that session. And so every single packet that goes through is authenticated. I know that Prashant and Kevin and the team are going to go into a lot of the security stuff later on, but rest assured, this not only is theoretical, this is freaking deployed. We've got this running on 5,000 auto parts stores. We've got this running in soon to be 10,000 pharmacies. So this is actually deployed. We're going to talk about some of those customers, but this is how we're able to route individual sessions. When that session return path comes, we are sure to route it on the exact same path back to the source. So that's how we're able to route individual TCP or UDP sessions. We can do cool stuff like take TCP and transform it to UDP in the network. We can handle carrier grade NATs. We can do origination or destination based NAT if you need to. So there's lots of cool things that are possible with this technology. We used to sell this by simply saying, give us the problem you can't solve any other way. Because there's a lot of cool things that that this allows you to do. And why does it matter? Well, first, by not using tunnels, this is an actual customer that replaced DMVPN with 128, and you can see on day 15 when they implemented Session Smart Routing, their amount of latency on a packet by packet basis was reduced by half, which reduced the amount of retransmissions, which improved their user experience. And it also matters because you can actually use the bandwidth that you pay for. You're paying a circuit provider for an amount of bandwidth, and you can say, well, I've got more bandwidth that I can use. Well, that's fine. But as you can see from the previous chart, there are certain points in the day, these microbursts and other things that may cause retransmissions. And again, it impacts user experience. So having that available bandwidth for the applications you're actually trying to run is super important. You can eliminate backhaul, additional bandwidth for backhaul. If you're connecting to the cloud, I mean, make no mistake, they're going to charge you for all the bandwidth that you're pulling in and out of AWS or in Azure, so you can optimize that. And you can do all kinds of things around optimized adjacency management. You can have fine-grained controls, and we'll see that more in some demos coming up here as well. I want to talk to you about a couple customers. So this is a auto parts chain. They've got 70,000 employees. They've got over 5,000 stores, and they figured out that every single telephone call that was dropped, and they were having somewhere in the order of 40,000 network outages a year, every single phone call that was dropped was leading to loss of $100. They actually figured out it's $100 per call. And so their challenge was they wanted to improve the quality of their network, but they're a retailer, and make no mistake, retail is a thin margin business. They wanted to decrease their cost. And so, they had, they're asking for more, but want to pay less. And so we partnered with, in this case, AT&T, to deliver a unified communications as a service for a single network. And so we're able to take advantage of, and these auto parts stores are in some really small towns. We were dealing with cable modems from like 1998 that were doing some crazy stuff. We're able to work with whatever broadband they had, whether it's DSL or cable modems. We're able to connect that together with LTE as backup, and we're also able to work with T1. So one of the big problems people have is they have contracts for circuits, and they're intrinsically linked where you have to deploy SD-WAN if you want to at the same time you refresh the circuit, which makes some sense. But if you want to decouple that and you want to take advantage of those T1s because you have, pick a number, a year, 2 years left in that contract, one of the big problems with SD-WAN is because you're wasting 30% of your bandwidth, you don't have the ability to do things like voice on a T1 because the SD-WAN itself takes up so much bandwidth. And so this was a way to leverage those T1s that were still implemented and provide seamless multipath routing across all three transports. And the results were pretty stunning. In 9 months, we were able to roll out just about all 5,000 stores. We were at our peak deploying about 65 stores per day. We actually have, it's 99.998 is the store availability. So just like 5 nines worth of reliability. And we reduced the number of tickets associated with the network by 90+%. So this, talk about, and I didn't even mention it, we reduced, working with our partner, the overall cost of the SD-WAN solution. We were 40% less expensive than competing solutions in this environment. So really exciting stuff. We're using, I think Lanner was our partner on this one for the hardware. We're using Silicom cards for the T1 interface, and yeah, it's just a great success story. A second one, we talk about retail. I'll talk a little bit more about the campus. So, you've got military bases in this example, and they want the servicemen and women to be able to execute their mission. And if the mission changes, the network should enhance the mission. It should not stand in the way of them execute their mission. And now, whether that's something simple like taking email and moving it from an on-prem exchange service to running in Microsoft Azure, or whether it's connecting and using both classified and unclassified networks on the same infrastructure. And so the solution that we worked out with our partner in this case is routing with sessions and not with packets. And the results are, we have the ability to move faster, so they can change their mission without having to reconfigure the entire network or have the network worse yet stand in the way, and able to provide improved end-to-end performance. So we're very excited about this. We were selected by one service. They're taking the same architecture now and deploying that across the second service. So this is a big success story. Move on to the next one. One of the largest oil and gas services company in the planet. So this is a company that has 2,000 plus oil drilling sites everywhere from offshore to fracking sites to Antarctica. And they're connected in many cases by satellite, as well as by potentially LTE or whatever bandwidth is available. And they are increasingly dependent on sensors to provide telemetry data to automate their operations. And we were able to allow them to take multiple paths, increase their network performance and reliability, while at the same time reducing their cost. And so we literally have, in fact, Reed, who presented earlier, has literally been through polar bear training, went up to the Arctic Circle deploying 128. And this is the technology that they use for those critical applications. Another example is a pharmacy chain. So we have over 10,000 between stores and the clinics, and they wanted to transform their network using software. And so they were really focused on a software solution that allowed for them to rapidly roll out new capabilities, whether that is store within a store, whether that was taking advantage of new transport as it becomes available, like 5G, whether it was connecting all kinds of new sensors and having the ability. Obviously, they have lots of healthcare data, so the ability to segment the traffic securely was super important to them. And so, again, we've won all 10,000 locations. We're, I think, a third or 2/3 the way through the implementation right now, and this is proceeding very, very rapidly. So those are a few examples. This is not theoretical. This technology has implemented, as was said earlier, in some of the largest networks in the world. And so, I'll close off by just talking about, 128 with Juniper. So, this technology has been in development since 2014. We've been heads down with people that know more about session-oriented IP communications than anyone on the planet. You now take that and you add that expertise to the world-class team at Juniper, sales, the partners, the support and marketing. We have a common vision with their focus on AI-driven operations, the ability to take that session smart data and plug it into the data model that's also managing your wireless and your wired network. And obviously, Juniper has a deep and rich heritage. 70% of internet traffic flows across Juniper products. And so Juniper knows an awful lot about routing. So marrying the marriage of these two companies, we're super excited about. So appreciate the opportunity to talk to you today. And yeah, we'll catch up with you. Kenny, I'll turn it back over to you.
Thanks, Tim. I really appreciate it. And again, thanks for joining us today. One thing that I heard you mention recently that really stands out in my mind, and as I look at other opportunities for our technology, is that, obviously SD-WAN, such a hot market. A lot of our business today is going through that particular use case. What do you see as sort of the next evolution of, where this technology can apply, and where do you see, if it's not SD-WAN, do you see an opportunity for customers to take advantage of this technology?
Well, honestly, we have kind of a tortured relationship with the term SD-WAN in general. When it first came out, it really, what it meant was overlays, centralized orchestration, and multipath routing. And we felt like Session Smart did so much more than SD-WAN. And so we kind of pushed back against, calling it SD-WAN in general. And then SD-WAN ultimately, from an industry perspective, began to mean, it was like soft switch in the voice world. It means kind of everything. And so we said, okay, fine, we do SD-WAN. But we always felt it was a use case. Some of our big implementations, some of the big ones that we're being pulled into, it's just router refresh. So if you got to refresh your routers, why in the world would you go with an appliance rather than seed the edges of your network with x86 and use the best-in-class software that you can possibly find? It just gives you so much flexibility, and it is where the puck is going. I mean, if you look at all the tools that are available now, it's just kind of where the future is going. Now, if that's scary and you want to just deploy a router refresh and you want to have the appliance-like experience, you get that too. So you can order, as was talked about earlier from our partners, hardware that is certified and has our software pre-provisioned on it. And so you have the ability to have that appliance-like experience. But again, it gives you the flexibility because now you've got x86, you can run it on other things. And so, in terms of other use cases, certainly SD-WAN, whatever that means to you. If it means multipath routing and single pane of glass, great. If you just want a new routed infrastructure and you just want manageable routers that are manageable at scale, I've got 2,000 routers, 5,000 routers, and I want that centralized kind of visibility, orchestration, and control. And oh, by the way, I want that orchestration and control, that visibility to also plug into what I'm doing with my wireless and wired network. All those things can stitch together. And so, you know, Reed gave you a little bit of a preview of what that looks like with Marvis. And look for lots of exciting things to come, you know, in the months and years to come in terms of as we realize the vision. So
yeah, thanks very much, Tim. Yeah, really appreciate your time.